Algebra 2, 6.2a, add or subtract rationals with like denominators, and I have a theorem for you. If you haven't seen the previous videos, I don't want you to get lost. There's links in this video's description so you can watch those real quick. When we add or subtract rational expressions with the same denominator, we add or subtract the numerators and keep the same denominator. It's the same rules we use for adding or subtracting fractions. So if we had 3/8 plus 2/8, it would be 5/8. We add the numerators. Or if we were doing subtraction and had 5/11 minus 2/11, we would just subtract the numerators and have 3/11. So here's our theorem. Addition of rational expressions for any rational expressions a over c and b over c, for which c is non-zero, because then it would be undefined, wouldn't it? A over c plus b over c would be the same thing as a plus b over c. And if we were subtracting, we'd have a minus b over c. We just slide that denominator over, don't we? So that's what we're doing here, and we're going to do it with rational expressions. If we add 3 plus x over x to 4 plus x, then we'd have 3 plus x plus 4 as our numerator and x as our denominator. And when we combine like terms, the 3 and the 4, we get a 7 plus the x. And this entire thing right here is equivalent to this one. Well, it says it's equal, so we know that, right? So they're equivalent expressions, and no matter what we plug in for the value of x, it's going to make it true for that one and for that one, see? If we did 3 plus 3, that would be 6 over 3, plus 4 over 3, then we'd have a 7 plus 3 over 3, see? Just like this. That's why you can't eliminate that x, because when you plug in a 3 for the x, this becomes a 10 over 3, see? If you think you can eliminate this with the quotient rule, you can't, because this doesn't equal 7, see? It equals 10/3 if we use x as a 3. And if x were a 5, well, then we'd have 7 plus 5 over 5. That would give us 12 over 5, see? So we need that denominator, so don't eliminate that, okay? Just leave him like this, and he's as far as we can go. He's simplified. Now for subtracting, we want to subtract. This is the subtrahend. This is what we're subtracting from this one. And what we do is we write it with one big fraction bar. And if we were to look at this as stacked, we could stack this one on top of this one and do the subtraction. You could very easily see we have 4x minus x, which is a 3x. And when you're subtracting a negative right here, then we've got a positive 5 minus a negative 2. We add the opposite. So remember, when we're subtracting a negative, we add the opposite. So we're going to add that 2 to the 5, and it's going to give us a positive 7. So we've got 3x plus 7 over x plus 3. Okay? Add the opposite. All right, when one denominator is the additive inverse of the other, we first multiply one expression by a -1 over a -1, and this will give us a common denominator. So we've got 9 over 2a plus this subtrahend of a to the third power over a -2a. Well, those aren't like denominators, are they? So we can multiply this subtrahend by a -1 over a -1, okay? That's going to give us a negative a to the third power over a positive 2a, because the two negatives make a positive, see? When we rewrite this over one fraction bar, we get 9 minus a to the third power over 2a, okay? And just remember, fractions can be written with a negative numerator or a negative denominator, or the negative sign could be right in the middle, couldn't it? All right? Let's try subtracting this one. This one's a little bit different. Here's our subtrahend, okay? And if you look at its denominator, it's not the same, is it? But basically it is. All we have to do is put this y in back here, all right? But if we did, we'd have a negative 2x plus y. So let's keep it like this for right now. What we're going to do is multiply this subtrahend by a -1 over a -1, okay? So that we can change the sign of that denominator. And what ends up happening is we get a negative 7x squared for the numerator, and this -1 makes that a -y and makes that a positive 2x, because two negatives make a positive. now we have negative y plus 2x, but we still need to get them like this. We can take this negative y and put it behind here, see, and get a positive 2x minus y, and now it's the same, okay? And we could have done it up here. We could have just put this positive y back here behind a negative 2x and then multiplied it. We would have gotten the same thing, okay? So now we have like denominators. We can write it with one big fraction bar, and if you look, we're going to subtract a negative. And remember, that means we're going to add the opposite. So instead of subtracting a negative 7x, we're going to add a 7x squared. See? That's going to give us an 11x squared over 2x minus y. Okay? So just remember to multiply the expression by a negative 1 over a negative 1 to change that sign. Our next video, 6.2b, we're going to add or subtract rational expressions with unlike denominators. I'm going to add this video to the Algebra 2 playlist for studying. I'm going to put links from Algebra 1 where we discussed this. There's 4 videos, and any of the previous videos that can help you for this video. Okay? I hope you're doing well, and I will see you next video. Bye.